Number 8 says, use the derivative to locate the critical numbers. Use the second derivative test to locate the local maximum and minimum. Should all work. So before we were using the second derivative to figure out where is it concave up, where is it concave down, where are the inflection points. The second derivative test, however, this is an alternate way of finding maximums and minimums. So it's an alternative to using the first derivative test. So if you look at the box above it, it says that the local max, a critical number is a local max if the second derivative is negative when you plug in a critical number. It's a local min if the second derivative is positive when you plug in that critical number. That basically comes from the concavity. So if the second derivative is positive, that means it's concave up, which means that it would be in the shape of a minimum. If it's negative, then it's concave down, and that would be in the shape of a maximum because it would be looking like a frown. And the big thing here is that if it's 0, then it's inconclusive. So you can't actually say if it's a maximum or a minimum. So it's kind of a weakness of the second derivative test. And then, as always, to get the y values of these actual points, you would need to plug the numbers into the original function. So let's start out with our first step, which is to take the derivative. So that's going to be 12x minus 3x squared. So then we want to find the critical numbers. So I'm going to set my derivative equal to 0. And then I want to factor, and I can factor out a 3x, which is going to leave me with 4 minus x. And then if I solve, x is going to be equal to 0, and x is going to be equal to 4. So those are my critical numbers, and I want to hold on to those right now. I'm not going to use them quite yet. I actually need to find the second derivative. So if you look back at the first derivative and take the derivative again, f double prime is going to be equal to 12 minus 6x. Okay, so here's the main part of the second derivative test. We need to plug the critical numbers from the first derivative, so the 0 and the 4. We need to plug those into the second derivative. So we're kind of mixing up our values here, because before we were plugging in like potential inflection points into the second derivative, and the critical numbers came from the first derivative. So here we're taking the critical numbers from the first derivative and then plugging them into the second derivative. So x is equal to 0 if you plug that in. 12 minus 6 times 0, we get 12. Now this is positive. So what that means is that there is a minimum at x is equal to 0. And let's plug in 4. So this will be 12 minus 6 times 4. And that should get you negative 12. So because that's a negative number, that means that there's a maximum at x is equal to 4. So the max and the mins, there's going to be a max at 4, comma 32 you get if you plug 4 back into the original, and then a minimum at 0, and if you plug that back into the original, you also get 0. So those would be the maximum and the minimum. Again, you could find these by using the first derivative test, but on this problem they specifically want you to use the second derivative test.